This is part 3 of section 7.1. We're going to talk about multiplying and dividing rational expressions. The rules for multiplication and division for fractions are exactly the same as they've always been. When you're multiplying, you're allowed to multiply straight across, and you can multiply straight across and then reduce, or you can cross cancel to reduce it before multiplying. That should really be the word and. Okay, we can only cancel on the diagonals when we're multiplying. It doesn't work for division, it doesn't work for addition or subtraction, only multiplication. The rule for division is the same as it always has been. Keep it, change it, flip it. Keep the first fraction, change it to multiplication, flip the second fraction, and then you know how to multiply already. We are reducing a problem to something already solved. Mathematicians do that all the time. We're lazy. If we've solved it once, we consider it done. Okay? So let's look at some problems. Multiply or divide as indicated, right answers in lowest terms. This is critical right here. We have to factor everything before we multiply or divide. I would love to tell you that you could forget all of chapter 6 and all the factoring, but it never, ever, ever goes away. Okay? All right, so this first problem, they have factored every numerator and every denominator for us. It is a multiplication. Now we can reduce a fraction up and down always, and we can reduce on diagonals always when we're multiplying. We just cannot reduce straight across. So if I look at this fraction alone, I have an x minus 4 and an x minus 4. So that one fraction reduces. Right here, we have an x minus 6 on both of these, so I'm going to reduce those. What I've done right here is I've reduced each fraction before I multiplied. Now we look on the diagonals. I have an x plus 3 here, and x plus 3 here on the diagonal, so those will cancel. And then these two do not cancel. So I multiply straight across now. All I have left in the top is x plus 5. All I have left in the bottom is x plus 2. Okay, so this is my answer to this multiplication problem. All right, so let's look at 6x plus 5 times x minus 3 over x plus 9 times x minus 1 divided by x minus 3 times 2x plus 7 over x minus 1 times x plus 9. Now everything here is factored for us already, so we just need to use the division rule, which we're going to keep this fraction the same, change it to multiplication, and then flip this fraction. Okay? So I'm keeping this first fraction the same. I see a huge number of mistakes caused by recopying incorrectly. It's like your brain says, okay, this is an easy step, let me go on vacation for a while, and then you make some stupid mistakes. So always double check that you have everything written down correctly. Okay, times x minus 1 times x plus 9 over x minus 3 times 2x plus 7. Okay, so let's look up and down and on our diagonals and see if we see anything that will cancel. Just looking at this one fraction, I don't have any factors in common, and I don't here either. Okay, so let's look on this diagonal. Do I have anything in common? Yes, I have an x minus 3 in both of those. Okay, now let's look on the other diagonal. I have an x minus 1 in both, and I have an x plus 9 in both. These two are different. We multiply straight across whatever we have left, and that would be 6x plus 5 over 2x plus 7. Okay, so let's work this problem. It's a multiplication, but this time things are not factored for us. So we have to go through and factor everything first. Okay, right here we have a difference of squares. The square root of t squared is t. The square root of the square root of 49 is 7. So that first fraction, the numerator factors as t plus 7 times t minus 7. And this is over. Okay. If I look here, I do not have a GCF. That's not a perfect square. So I would be looking for two numbers that multiply to a negative 21 and that add to a 4. And 7 and 3 will work if I make the 3 negative. Double checking, yes. So this factors as t minus 3 times t plus 7 times. Okay, here. Again, no GCF, not a perfect square. I'd be looking for two numbers that multiply to 15 and add to an 8, which would be a 3 and a 5. So this is t plus 3, t plus 5, and this is over. Now the bottom here, again, no GCF, not perfect square, looking for two numbers that multiply to a negative 35 and that add to a negative 2. 5 and 7 multiply to 35. If I make the 7 a negative, all my signs work. So this is t plus 5 times t minus 7. Okay, so let's look up and down for each of these fractions and see if we can reduce them first. On this one, I have a t plus 7 in both of those, so that will cancel. Here I have a t plus 5 in both, so that goes away. Now look on your diagonal. Here this is t minus 3, this is t plus 3. These are very different. Okay, and then I have a t minus 7 in both. The only thing I have left is t plus 3 over t minus 3. This is your answer. You cannot simplify that any further than you have already.